In this video, the learner will determine the distance between 2 points on the number line and the length of a segment. First, let's uncover a few vocabulary. We have a line segment that is a piece of a line that has 2 endpoints. So we have an example of a segment here. The endpoints would be the points K and J. To name that segment, we use its endpoints. So K, J would be the segment. You could also use JK. Notice the symbol above is different than a line. The symbol that you use is very important. It means that we're talking about the segment and not the line. If you use the notation without the symbol above it, so just KJ, it means the measure of the segment. It's the numerical value that represents that length of the segment. When we talk about betweenness of points, any point on a segment between our 2 endpoints is said to be between when they are all 3 collinear and the measure of Km plus the measure of Mj is equal to the whole segment Kj. So the distance here plus the distance here equals the entire distance of the segment. When we talk about congruent segments, if one segment can be mapped onto another segment using rigid transformations, then the segments are congruent. That's also to say 2 segments are congruent if and only if their measures are equal. So I have segment AB here and segment EF. If I can map EF onto AB or vice versa, they would be considered congruent. So if I were to translate EF over and flip it, notice I can map that segment directly onto AB and the endpoints line up, therefore they are congruent. So we can say that these segments have equal measure. So the way we would represent that symbolically is we would say segment AB is congruent to segment EF. We use the congruent symbol when we're talking about the objects. Segments are congruent, but measures are equivalent. So when we talk about the objects, we use the congruent symbol. When we're talking about the measures, we use the equal sign. In these examples, we're going to use betweenness to find actual measures. So here we have example 1, and we have the segment EG with F between. So we have EG is the measure of segment EG. Point F is between E and G. Because it tells us point F is between, we know we can use betweenness of points to help us solve this problem. We're going to find EG by adding EF and FG. So using betweenness, we know the measure of EF plus the measure of FG equals the whole measure EG. So 2 3/4 plus 2 3/4 is equal to EG by substitution. When we put those together and substitute again, we get 5½ inches. That's equal to the measure of EG. In example 2, we have point B that's between points A and C. The measure of AC is 13.2 meters. The measure of BC is 5.8 meters. We can use betweenness of points to set up an equation here. AB is the piece that we're missing. BC is 5.8 and AC is 13.2. So we can substitute those values in, subtract 5.8 from both sides, and substitute to get AB equals 7.4 meters. I want you to use betweenness of points on examples 3 and 4 to solve for JL in example 3 and for QR in example 4. Using algebra to find measures, we have find the value of A and the measure of xy if point Y is between point X and point Z. The measure of xy is equal to 3A, xz is equal to 5a minus 4, and yz is equal to 14. So we have expressions that represent each one of those values. It will help to draw a figure to represent this. So let's draw our figure here. We have y that is between x and z. xy is represented by the expression 3a. yz is represented by 14, and xz by the expression 5a minus 4. We know with betweenness we can set up this equation, xz is equal to xy plus yz. Now we can use substitution to plug in the values of the expressions that represent each piece. Now we just have an equation to solve. So first we're going to subtract 3a from both sides, substitute to get 2a minus 4 equals 14, add 4 to both sides, substitute to get 2a equals 18, divide by 2 on both sides, and substitute to find the value a equal to 9. We were also asked to find the value of the measure of the segment xy. That's represented by the expression 3a. Well, we now know the value of a. We can substitute our value of 9 in for a and get a value of the measure of xy equal to 27. I have an example 2 here that I want you guys to try. Find the value of x and the measure of BC if B is between A and C, and the length of AC is equal to the expression 4x minus 12, AB is equal to the expression x, and BC is equal to the expression 2x plus 3. It will help to draw a picture first. Now let's talk about distance on the number line. We know distance is the length of a segment between 2 points. So we have the number line here, and we can find the distance between 2 points by counting the spaces. So if we want to find the measure of segment BE, all we have to do is start at one of those points and then count to the other one. So starting from B, there's 1, 2, 3, 4, 5, 6, 7, and 8. So from B to E is 8 units. Now the coordinates of B and E are at -6 and +2. Think about how you could get that 8 units using the coordinates. It's also worth noting we did move to the right. What would happen if we moved to the left? Would the distance still be 8? The answer is yes, because distance is never negative. Even though we can move in a negative direction, the distance or the length between the points is still positive. Now I want you to determine whether the measure of CA and the measure of ED are equal to therefore make the segments congruent. Next, I want you to do these examples on the number line. You have the coordinates for P, M, L, R, S, and N, and you're finding the length of the segments indicated below. I also want you to think about this example with P and Q here, where we have coordinates of x1 and x2. Can you derive a formula using the coordinates?